graph of object in uniform motion. So today in this video you will learn about the distance time graph for uniform and the non-uniform motion. So example is given. Let us suppose that the motion of a cyclist is observed every 15 minutes on the road. So distance traveled from 9:30 is observed and noted down in the following table. And uniform motion means equal distance covered in equal intervals of time. So let us see the example. Time from 9:30, 10 meters completed, 9:45, 20, 10, 30, 10:15, 40, 10:30, 50, 10:45, 60 and 11 o'clock 70. So we have to plot this data on the xy plane. So let's see the graph. How you make a line xy and y axis. So horizontal line, this one, the x axis, and the vertical line, the y axis. Now with the help of scale, you will remember in the x axis time and in the y axis the distance you will show. And in x axis the time is noted here as 9:30. Now use the scale which should have the same measurement. If you are taking 1 centimeter gap, so 1 centimeter gap should be present in every scale, in the distance also and in time also. So 9:30, 9:45, 10 o'clock, 10:15, then we have the 10:30, then 10:45, 10:45 and then 11 o'clock. And here the distance 10, 20, 30, 40, 50, 60. So in this way you will divide the scale in equal times measurement. So first the distance travel was 10. So at 9:30 distance travel was 10. With the help of scale you will draw here. Then at 9:45, 20. At 10 o'clock 30. At 10:15, 40. And at 10:30, 50. 10:45, 60 and 11 o'clock we have the 70 meter distance has been covered. So with the help of scale you will make a plot and intersect and then draw a line with the help of scale. A straight line has been drawn here. So what type of motion is shown here? Uniform motion. And in uniform motion the graph will have the straight line angle, that is the inclination line. The line will be in a straight line. Now on the graph we see a straight line inclined to x-axis or time axis. Here the distance traveled is directly proportional to time. So therefore we can predict that equal distance being covered in equal intervals of time. And this is the graph of uniform motion. Further, the inclination or slope of the inclined straight line gives the speed of the object also. Steeper the line or higher the slope of the line will show the greater speed and of the object, and also lower the slope will show the low speed of the object. So according to the slope you can also predict the speed of the object. If slope is drawn in a higher slope, then it will show the higher speed, and if the slope is drawn in lower angle, that is in the lower line, the slope will be a low line, then the speed will be also low. So look, let us see the example here. Plot the distance time graph for 3 different cars A, B and C covering 200 meter in 4 seconds. Then we have the 10 second and 20 second respectively. Now see here, A, B, C, 3 different cars have been shown by the different colors. A red, B green and C blue. So which car is showing the greater angle? Greater angle will be shown by A. And which will have the moderate? B. And the smallest? C. So which line is showing the least slope? That is line C. C car is showing the least, and it means the speed is low. B is showing the moderate line. The angle is moderate, but not too much higher or lower than the A and C. So it has the moderate speed, and A is showing the highest angle, will have the highest slope, and it will also speed and car A. So in this way you can predict the speed of the object according to the slope. So we can easily predict from the graph it travels 200 meter in minimum time. So it is the fastest car and has the highest slope, while car C travels the same distance of 200 meter in maximum time. So it has the slowest and has the lowest slope. So car C will have the slowest. It has the lowest speed and the lowest slope. So according to the slope, you can say the speed of the object. Now comes to the distance time graph for the non-uniform. Non-uniform motion means the when object completes unequal distance in equal intervals. So we have already learned that when an object covers unequal distance in equal intervals of time, then the motion of object is non-uniform. For non-uniform motion, the speed of the object is not constant and keeps changing. So let us see what type of graph we get when an object depicts non-uniform motion. Example has been shown here. The distance covered by a motorbike in the road is recorded as 2 meter in 1 second, 10 meter in 2 seconds, 20 meter in 3 seconds, 39 meter in 4 seconds, and 60 meter in 5 seconds. So according to now we will draw the graph and you will see what type of line is drawn here. So let us plot the data. First of all, make x-axis and the y-axis. On x-axis, plot the time 2 seconds, 3, 4, 5, 6. And here plot 10, 20, 30, 40, 60, 50, 60. And remember, the measurement of scale should be equal. So here, when we draw the line, plot first of all at 0, 0, 0 initial. But the second one, that is at 1 second, the distance has been traveled just only 2 meter. So 2 meter is 2 meter in 1 second. 2 meter in 1 second. Then in 2 seconds, 10 meter has been completed. Here, with the help of scale, you will draw. In 3 seconds, 20 meter has been completed. But in 4 seconds, 39 meter has been completed. And in 5 seconds, I think 60 or 50, 60. In 5 seconds, 60 has been completed. And now you will draw a line. So line is not drawing straight, but it is going in a curved line. So curved line shows that motion is not uniform. It is non-uniform motion. So according to this, we can draw the graph. So in this case, we do not get a straight line. Instead, we get a curved line. So this means that the distance traveled is not directly proportional to time motion. And also from the graph, we can predict that a curved line indicates unequal distance in equal interval of time. And also from the curved line obtained for the distance time graph, we can infer that the speed of the object is also non-uniform. Some examples are given. The motion of a cyclist is observed and recorded in the following table. What are the distance? 0 at 0 meter, 0 second. At 10 meter, 2 minutes, not second, minutes is shown here. 20 meter in 4 seconds, 30 meter in 6 seconds, 40 in 8 seconds, and 50 in 8 minutes, and 50 in 10 minutes. So on a graph paper, draw a horizontal line OX and vertical line OY mutually perpendicular to each other, and they will meet at point O. So O will and mark the point 0, 10, 20, 20, 40, 30, 40, 50 on the OY, and here 2, 4, 6, 8, 10. So scale measure should be equal. You would either you take 1 centimeter gap or 2 centimeter gap. So you will draw the line here and then divide the scale equally. 1 centimeter gap should be there, and write all the here the time is shown in minutes. So 2 minutes, 3 minutes, 2, 4. Then we have the 6, 8, 10. And according to the graph shown here, according to example, at 0, 0, you will write 0, 0 here. 2 second, 10. At 4 second, 20. At 6 second, 30. At 8 second, 40. and 10 second 50. At 10 second 50. So in this way you will plot a dot, and now draw line. What type of line you are drawing? Straight line with the help of scale. So this shows that this graph is showing the uniform motion. So remember, for the uniform motion, the line will be in straight line. So angle of inclination line will be in a straight line. Now come to the next. A car moves from point A to B, point E, and the distance covered by it in various times is shown in the table. A, distance kilometer 0, 0 minute. B, 5 kilometer in 20 minutes. C, 15 kilometer in 45 minutes. D, 30 kilometer in 70 minutes. E, 40 kilometer in 100 minutes. And F, 60 in 120. So first of all, you will write the time on the x-axis, 20, then 40, then 60. In this way you will make the gap. And here also 10, 20, 30, 40, 50, 60. So on a graph paper, draw a horizontal line OX and the vertical line OY, and then mark line O in the intersection point, and then plot the time in minutes and distance in kilometer. So divide with the help of scale, that is 1 centimeter gap, 20, 40, 60, 80. You will divide the lines 100, 120, and 10, 20, 30, 40, 50, 60, 70. So equal distance should be there. Now what you will do, you will now you see the example how the for the A 0, 0, 0, 0, for B 5, 5, 20 minutes, 5, 20 minutes. Then we have the 15, 30, 40, 60. So in this way, 5 meter in 20 seconds, 20 minutes. Then we have the 15 kilometer in 45 minutes, and then 30 kilometer in 70, then 40 in 100, and 60 in 120. Now with the help of scale you will draw this line, and how the line is drawn here, it is not straight, it is curved. So from the graph being a curved line, we say that motion is non-uniform. So chapter is completed. I think you all have understood about the 3 different types of graph, that is the horizontal line graph, the graph for the uniform motion, straight line graph, and the curved line graph for the non-uniform motion. Now come to the checkpoint. The standard or basic unit of hour is, standard or basic unit of time is hour. False. If an object covers equal distance in unequal interval of time, the speed of object is constant. False. It is not constant. The distance time graph of stationary object is straight line. True. Higher the slope of the line inclined to the time axis, greater is the speed. True. Sundial and the water clocks are used to measure time in ancient time. True. And the time taken to complete 10th oscillation by a simple pendulum is called its time period. 20. Odometer measures the distance traveled by a vehicle. True. And the distance time graph of an object is non-uniform motion, is a straight line inclined to time. False. It is a curved line. So you will write the checkpoint.